Wow, plane taking off. Wow. Wow, got the... See. Uh-oh, Dr. Romano, are you out here watching the planes take off? Getting ready for a vacay, I guess. Hey, Dr. Romano, what are you up to?
The only thing I want to see taken off is this really great problem I've created. This is designed for a student that's going for a 30 on the DAT exam.
That would be me.
If you're not going for a 30 and organic is really not your thing, move along. Don't waste your time on this video clip. For the kids that are really serious, let's get rocking and rolling. The first thing I want to do is I want to take an ACL halide, and I'm going to treat it with a Lewis acid catalyst, and I'm going to get product number 1, and then I'm going to do the Wittig reaction, and that's going to give me my final product. But I'm going to do the mechanism out so you can understand the way the arrows have moved. So you should be able to focus on that and understand the little things in between. Now, when I write a circle with a line through it, this is what we do in advanced organic chemistry. It just means a phenyl group. So if that notation bothers you, that just means the phenyl group. So what I'm going to first do is to take the ACL halide and make it attack the empty orbital on the aluminum, which functions as a Lewis acid catalyst. And as you can see, we now combine and we simply do a Lewis acid base reaction, with the Lewis acid being the AlCl3 and the lone pair of electrons from the chlorine here acting as the Lewis base. Once we now have this group is going to be my leaving group. The bond moves down and we form this weird looking intermediate which goes by the name of the acylium ion, since it came from an ACL halide derivative. Now, once we have the acylium ion formed, even though oxygen has a positive charge, and a lot of kids are very uncomfortable with this, it still has the octet, which means this is a highly stable resonance contributor. Now, what I've done with the acylium ion is I am now going to do what we call an intramolecular Friedel-Crafts reaction. And as you can see, I've taken the benzene ring, make that act as my nucleophile, and as you can see, we're going to use this portion as the electrophile. And we're going to do the reaction known as electrophilic aromatic substitution. And as you can see, I take these electrons, move them here, and I cyclize them. Then a Cl minus, which came off the AlCl4 minus complex, pulls off an H, and as you can see, we gain the aromatic carbonyl here. Now, I didn't draw all the resonance forms of this, but as you can see, I wrote etc., meaning this would have resonance. Okay, now we're here. We now form a molecule called tetralone. This molecule is now going to be treated with the phosphorus ylide in the Wittig reaction. And as you can see, the Wittig reagent, the ylide, launches a nucleophilic attack to form the intermediate beta-ane. The beta-ane, as you can see, collapses. And as you can see, we now make it into what we call an oxaphosphatane intermediate. And then finally, we form the PO bond, and this moves down, and you get your carbonyl chemistry and triphenyl phosphine oxide. So this would be the major product. So a good question for the DAT would just be this and this. So when you first treat it with aluminum chloride, you would have first formed this molecule here. That would just be, all you would really do is to take off an H here and a Cl here and combine them. We got a question like that in the DAT Destroyer. And then I just made you continue on and made you do the Wittig reaction. The DAT got a little tougher, and to get a 30, it's not so easy. But if you can do this problem, I think you're in great shape for a perfect 30. And like my guys here in New York, this DAT exam will be a piece of cake. So if you got any more questions, hit me up on the study group. You don't need to spend any money on any videos. I'm doing them all for free. So if you got a video request, let me know and I'll be happy to do them. Many professors and PhD scientists give free videos. So don't get sucking into buying any videos and spending any money. We'll do it free for you. All right, guys, I'll see you in study group on Facebook. Bye-bye.
Dr. Romano, it's awful hot out here today. Are you going to go to the beach?
I don't like beach and I don't like swimming. I'm going to actually probably do a Grignard reagent after this, and I'm even more excited, so bring it on. Bye-bye.
I'm going to the beach, Dr. Romano. Good day to you, sir. Good day to you, sir.